Algorithm. An algorithm is a step-by-step procedure to solve a problem. Here, problem is a computer problem or a computer program. We write those programs with the steps, what we are going to do. Similarly, we have flowchart. It's a graphical representation or a pictorial representation of those steps of a program, what we have done, what we have written using a algorithm. Now, in order to show that in a graphical way, we need certain shapes. A symbol, the basic symbol, is a oval shape which always represents the starting or ending of my flowchart. So we have an arrow mark here. So this arrow mark acts as a connector between each and every steps or an operation what we perform for a particular problem. The next shape what we have here is a parallelogram. So this is used whenever we give input or we display the output in our program. The next shape is a rectangular shape. So this is used for a processing purpose. Maybe in our program we are going to add something, we are going to subtract something. So certain kind of operation we are finding greater, smaller. In that case we use this particular shape. The next one or the last one is a decision making. So that is using a diamond shape. So this decision making is normally whenever we need certain checking has to be done in my program, whether the number is greater or smaller, something like that. In such cases, in order to take the decision, we use this diamond shape. So now let us see how to write an algorithm as well as the flowchart for a given problem. Now let's see our first problem, adding two numbers. It's a very simple problem of adding two numbers. So this is what I have, a ready-made algorithm for that. As I said earlier, it's a step-by-step instructions, right? So we have written every steps has to be followed in a particular order. So the step one, normally the first step and the last step will be starting and ending of the algorithm. So with that note, I have started my first step to add two numbers, saying that it's a starting of my algorithm. Now what is my second step? Okay, in the second step, whenever I want to add two numbers, I know that I need to accept two numbers, any two numbers. Okay, any two numbers. So that is why the second step is the data variable declaration. Means I have to tell that how many numbers I am going to use in my program. Number in the sense, the numbers are not actual numbers here, they are in the form of names. So you can see here, we have given a name as number 1 for the first number 2 for the second number, and when I add them, I'll get a certain result, right? So the result, in order to store that, I have used one more name or a variable, we can call it as, or a data variable. So that is what is a sum. So this is what is my second step. In the third step, what I've done is I have read the data. I am reading the data. Maybe I'm entering it through the keyboard or whatever. So give me the first number, give me the second number, or read the first number, second number. So once I get the two numbers, then I need to perform certain operation on that. What is that operation? Yes, of course, this program is to add two numbers. So that means I have to calculate the sum of two numbers. So that is, I said that the first number, whatever I have with me, that I have to add it with the second number. So that's why I have used here plus symbol for the addition purpose. Once I add them, I get a result, and that result I'm storing in a variable or a data variable called as a sum. So that is what we have declared here. So now my answer, the final result, will be in a variable called as a sum. In the next step, what else I have to do? Just I have to display it on the screen, right? So I said the step 5 is to print the result. So I said display sum or output sum, whatever terms you can use it. And at the end, yes, my program is done now. My problem is solved. I have accepted two numbers. I have added them, and finally I have display the result. So that's where I'm going to stop it now. So this is the algorithm. Now let us see for the same problem, what is my flowchart, how my flowchart looks like. In the flowchart also, we started with the start symbol. What is that symbol? Oval symbol. And the same time, my flowchart also ends with another symbol. That's the same symbol, oval symbol, which is used for stopping it. Now, once I start my flowchart, the second shape, what I'm going to use is a rectangular shape where I am declaring, like I am using number 1, number 2, and the sum are the three data variables. Yes, once I declare them, reading, what I have to read, as we have just now seen in an algorithm, read two numbers. What are those two numbers? Number 1, number 2. Here we can write it separately also, like read number 1, and then second line I can say read number 2. Instead of that, I have, in a single line I have written it. In the third shape, so, but if you observe here, the reading is done using that parallelogram, isn't it? So parallelogram is a shape, as I told you earlier, it's used to reading as well as displaying, correct? So in two places I have used a parallelogram. So this is for the reading purpose. The next is a processing. What processing I'm doing? I'm just adding two numbers and storing the result in the third data variable. That is what is a sum. Now finally I'm going to display. Result is in sum, so I'm displaying it. So display sum. So the shape what I have used is again the parallelogram. And finally I'm going to stop it. So this is a simple algorithm as well as the flowchart to add two numbers. Now, suppose you want to say subtract two numbers. Just you have to replace plus by star. Minus. You want to multiply two numbers. Just replace the plus by star. Division. Just replace plus by division symbol. So that's all. So you can use these two algorithm as well as the flowchart. By replacing this symbol or an operator, you can use it for anything. Now, so we have the second one, that is to find the smallest or the minimum of two numbers. Here, if you see, my algorithm starts, and in order to find the minimum, again, I need two numbers. I have just named it here it as A and B, and to say which is minimum, for that purpose, I have used one extra variable, min. Now, so once I decide I'm going to add two, find the minimum of two numbers, the next is I have to accept two numbers. So that's why we have reading A and B. So once I get my two numbers, what's the next step? I need to check here. This is the extra step what we have in this particular algorithm, because here we are going to find out the smallest or the minimum among two. So that is why this checking step. In this step, I'm checking whether the first number which is there in A is lesser than B. Why? Because smallest. So lesser than B. So if this can be a true as well as false, isn't it? There are two answers for me for this particular question. A may be lesser than B is true, or A lesser than B is false. If it is true, what is the meaning? Yes, we got our minimum number. So where is our minimum number? Is going to store in a min variable. So I said min is equal to A. Then you stop it. Stop it in the sense, go to the step 5 here and display that minimum number and stop. Suppose my A less than B is not true. It is false. Go to the next step. So what it's saying, if it is false, you say minimum is B. Means the second number is the minimum, right? Then minimum, if you get the minimum number, then nothing else. Just go to the step 5, display the minimum number and stop it. So here, in this particular case, any one of them is going to be the minimum. Now, same procedure. You can, repeat it for greater also. Here, this is the smallest or minimum. You can make it, or you can convert this algorithm for greatest or maximum. Just replacing this lesser than symbol by greater than symbol. That's it. So now next we have the flowchart for the same. So this flowchart says start, then declare whatever variables, data variables you are using in your, program. Yes, I am using A, B, min. Then after that, you take the values for A and B. Once you get the value, you're checking here with this is the decision symbol we have seen earlier, right? So this is a checking symbol where you're checking if the A value lesser than B. If true, then what? Minimum is A. If not, if it is false, minimum is B. In both the cases, it has to print the result and then it has to finally stop. But again, any one is going to happen here. Now our third program. So what is this third program? It is to find the list of three numbers. Okay. Before that, we have seen minimum of two numbers. So this is going to check the largest of three numbers. Okay. So again, I said start. Then I'm using three numbers, right? So A, B, C, largest. So I'm using max. Then what is my step 3? So reading all the three numbers. Then initially I assume that I don't know which is the maximum here, but I assume that the first number, whatever I'm accepting, that is A, right? So I said max is equal to A, means whatever is the first number, let me assume it as a maximum number. Then let me start checking it. So I said checking. What is the checking? I have to check the second number B, whether it's greater than the first number. That is, what is the first number? Where is my first number? That is in max. That is, I have taken as a max, right? Now check the second number, whether it is greater than the max. If it is true, then you say the second number is a max. Just replace it. Otherwise, what if it is not true? What will happen if it is false? Then go to the next checking. Where is that next checking? Step 6. If it is true, then go to the next check. It means in both the cases, you need to come to this particular step. That is step 6. So here what you are doing is you are comparing the third number with that maximum number. In case if the third number is, that is C is greater than whatever is the maximum number, then you are saying that the maximum is, you are replacing maximum as the third number. Then you are displaying that maximum and you are going to end your algorithm. Otherwise, you assume that if it is not greater than the third number, which is the greatest, the max itself is the greatest, right? So then now no need to check again. Then go to the, again you have to display. Go to the step 7 is a compulsory here. Display the maximum number and you are going to end your algorithm. Now for the same algorithm, you can use it for the minimum also. Just replace this greater symbol by lesser than symbol. Now, for the same algorithm, we have a flowchart here. So initially we say start. We are using 3 variables for accepting 3 numbers and 1 to assuming as a max. Next, reading all the 3 numbers. Then you are assuming the first number A as a maximum number here. Then you are checking the second number whether that is greater than the maximum. Maximum is the first number. Remember that. So if it is true, then check with the second number. You are assuming that second number is a maximum number, and then you are checking that max with the third number. And if the third number is the greatest, again you are assuming that third number is a maximum and you are going to display it and end it. Suppose the second number is not a maximum, it's false. false. Then what you're going to do it? You are going to check the third number is the max, and that again gives you either true or false answer. If it is true, then you're assuming that maximum is the third number. If it is not, then you're directly displaying that max as a greatest. So this is an algorithm. Again, this algorithm can be changed to find the smallest of three numbers by just replacing this greater symbol by smaller symbol. Now we have the next one. What is that? Algorithm and flowchart for calculating the sum of n numbers, and same thing you're going to print it. Now let's see how to calculate the sum of the numbers. N numbers. What do you mean by n numbers? N numbers means we don't know the limit. That's a limit. It can be a 2 number, it can be a 3 number, 4 number, etc. So now, as like earlier, we have just started our algorithm. Then we are just declaring. At the same time, we are giving the initial value. That's why it's called as initialization. You can just write declaring also here. As I said, we don't know the limit. So n is capital N number. It's a limit. This is what is the limit here. We don't know whether number is 2 or 3 or 4. So when we don't know that number, what is our number, we need something called as a counter. So this is here the I variable acts as a counter, whether you have reached, where you have accepted first number or second number or third number, etc. So in my case, what I have taken is I as initialized to the value 1. 1 means my counter starts from value 1. Okay. Now, so I'm going to finally calculate the sum, of course. So that's why initial sum value I have set 0. Then to accept one by one numbers, I have used one extra data variable x here. So this x represents my numbers, what I am accepting. Okay. Now, so what I will do, reading the limit value n, it means I have to first ask the user how many numbers you want. So the user may say I want 3 numbers. So what is my n here? N becomes 3. So when n becomes 3, my I counter has to increment like 1, 2, 3 up to 3, because my n limit is 3. If my n limit is 10, then I counter, this I counter needs to be incremented till 10. Once it becomes 11, stop it. No more incrementing, no more accepting the numbers. So in that way, here, imagine that. So reading the n is the limit, that is 3. So now next what? I have to check whether the value of the counter is lesser than 3. Yes, I is initially 1, right? I is lesser than or equal to 3. Yes, true. When it is true, you take first number, you accept first number. So your first number will be in x. So whatever is that first number, you are going to add it, right? So you are adding it to this old value 0. So 0 plus my first number. Suppose my first number is say 3. Now 0 plus 3 will become a 3. So what is my sum now? 3. Now next counter has to be incremented, right? In order to accept the second number. So what is my I now? I becomes 2. Again, when I becomes 2, I need to repeat the checking. What is that checking? Whether that I counter value 2 is lesser than or equal to my number 3, maximum number 3. Yes means again accept the second number, add it to, then again increment the counter. So this you are continuing till your counter and your limit are equal. So once your counter value is more than your limit, it means you have to stop there. No more accepting the numbers. So once you stop there, your sum is already calculated over here. Then you are going to display the final sum and you are going to end your algorithm. Now the same algorithm in the form of flowchart. See here, we have started it, we have taken the counter, we have taken the sum initial value, we have taken number, and n also we can declare here. Then you are reading the limit. Once you read the limit, you are checking whether the counter value is equal or lesser than the n. So yes, it is true means you are reading or accepting the number, you are calculating the sum. Same time, in order to accept the second number, you are incrementing the counter and it's going to repeat. So till I is less than or equal to n. So once the I value counter value exceeds the limit, that becomes a false. When it becomes a false, you just print the sum and stop your thing. So that's all.